Hey everyone, this is our video on empirical and molecular formulas. So by the end of this lesson, you should be able to analyze quantitatively the composition of a substance, and we're going to be focusing on empirical and molecular formula today. Before you get started though, you may want to go back and review percent composition because you will have to use that for empirical formulas. So let's start with empirical formulas. And when we say empirical formulas, we are looking at the simplest or lowest whole number ratio of atoms in a compound. So we are really looking at ionic compounds here because they're the only ones that reduce to the lowest whole number ratio. Our steps to solve for empirical formula. The first one is you're going to take your percent, so your percent composition of a compound, and you're going to switch them to grams. That's not the only step. There we go. Then you're going to go from grams of those elements to moles of those elements. And you do this by dividing by the molar mass from the periodic table. Then once you get those, those answers will be moles. And you're going to divide each of those by the smallest moles that you just calculated in step 2. That is what's going to give you your subscripts. Remember that subscripts want to be whole numbers. So if you don't have all whole number subscripts, you have to multiply them by a value to fix all of them. So you can't just multiply the one that's not a whole number. If you see that you have a subscript that's a 0.5, you're going to multiply everything by 2. If you see you have a subscript that is a 0.25 or 0.75, you're going to multiply by 4. And if you see one that's a 0.33, you're going to multiply by 3 because, again, that will get you to 0.99, which you can round. Okay, so we are getting into some math here. So let's look at this example. It says an unknown compound contains 68.4 grams of chromium, 31.60% oxygen. So find the empirical formula. So that's what we want here. So our first job is to take those percents and switch them to grams. Not a math move, just change the unit. Once you do that, you're going to divide each one by their molar mass, again, from the periodic table. So the molar mass of chromium is 55.85. The molar mass of oxygen is 16. Once you get those, that comes out to 1.25 moles of chromium and 1.87 moles of oxygen. Well, 1.25 is less than 1.87, so you're going to divide both of them by 1.25. And this is what's going to end up leading to your subscript. So 1.25 divided by 1.25 is 1. 1.87 divided by 1.25 is 1.5. Remember, we cannot have half number or decimal subscripts. So we're going to take each one of these and we're going to multiply them by 2. That's going to give us a final answer of Cr2O3. No whole number subscripts, so we've got to multiply that one by 2. So now I want you guys to try this example. Okay, pause the video, try this example. Now that we know a little bit about empirical formulas, we're going to take that a step further with molecular formulas. So molecular formulas are the true or exact formula. Okay, so this is the one we would see represented. We're looking at molecules here, so covalent compounds. And it is usually, well, it always is, a multiple of an empirical formula. Sometimes you will have an empirical formula and molecular formula be the exact same. Not all the time, though. So for these, the steps are not much more difficult. Sometimes, depending on the problem, there we go. You have to find the empirical formula first. A lot of times, though, to speed up the process, this tends to be given to you, but not all the time. So like on an honors page or AP, they may expect you to find the empirical formula first and then keep going. Sometimes it could be given on a multiple choice question to speed things up. After this, you have to find the empirical formula mass, or the EFM. You just do that by adding up the masses on the periodic table. I don't know why this doesn't work all the time. Then you're going to take the molar mass, and I want to make a note here. This molar mass, that is going to be given to you. You're never expected to know that molar mass. So the molecular or the molar mass, you're going to take that and divide it by the EFM you just calculated. This is going to give you your multiplier. So you're actually going to take that and multiply your empirical formula. There you go. Okay. By the multiplier that you just got. And that's going to give you the molecular formula. So if you have a formula of CO2, but then your multiplier is 2, now your formula is going to be C2O4. So there's an example. You have your empirical formula. Well, you took that empirical formula, you multiplied it by 6 as the multiplier, and that's going to give you the molecular formula for glucose. So here's an example. Let's go over this. A compound is made up of 74% carbon, 8.7% hydrogen, and 17.3% nitrogen. The molar mass is 162.1 grams per mole. What is the molecular formula? Keep in mind with this, I am doing a harder one here because I am making you start with empirical formula. So if you do the empirical formula following the last example, you take all of those percents to grams, divide them by their molar masses, then divide those answers by the lowest moles you calculated. You'll come out with an empirical formula of C5H7N. Once you do that, you have to figure out the empirical formula mass by adding those up together, and that would be 81 grams per mole. You're going to take the molar mass that was given and divide it by 81, which gives you a multiplier of 2. And then you're going to take the entire formula that you had originally and you're going to multiply it by 2. So this 2 is going to multiply on each one of those subscripts, making it C10H5